Today we look at solving quadratic equations and some mechanics. Remember, a quadratic equation can generate a parabola that represents the path of a projectile. And we've seen different kinds. We've seen a low one like this, we've seen some medium ones, and we've seen some sort of high ones like that. Now we know that if we are looking for the vertex, we can use this process called complete the square. And that allows us to find the vertex here or the vertex there. If we're not looking for the vertex, if we're looking for the initial and final values, so this value down here and this value down here, and we don't really care about that, we don't need to find it, and we don't need to complete the square. We need to find another technique. So let's try an example here. Consider the height of a soccer ball. Here's our quadratic, negative leading coefficient, so we know it's upside down. A initial height of 0, so that puts the soccer ball right at 0. And our initial, what we call it, the initial launch slope, I guess, 3 of heading off in this direction. To be able to find this value and this value, we notice that the height of the ball, if this was like, say, 4 meters, 3, 2, 1, 0, the height of the ball is 0 when it's on the ground here and on the ground here. So equation-wise, what we do is we set this height, we're going to set the height equal to 0. We make the height in the equation equal to 0, and then we solve for t. And what we'll get is we'll get the t value here and the t value here. This will tell us the time when the ball is on the ground, at the start and at the end. So just before we do that, I want to take a look at a numerical example. And there's actually an interesting property that we're going to use and take advantage of. So just think for a second here. Suppose I given the following, 0 equals a times b. By inspection, just by looking at it, what do I know about either a and b? Just think for a second. If a times b is 0, then what has to be true for either a or b? And what has to be true is that either a or b must be equal to 0. That's the only way. To get a final answer of 0, one of these has to be 0. And that's actually called the zero product property. To get a final product of 0, a or b must be equal to 0, either one of them. So we're going to try this. Solve the following quadratic equation. So our rule so far is, okay, solve for x, isolate for x. I say I have an x here, an x here. I could go x squared plus 9x. We've learned to, subtract 14 from both sides. So that would be equal to negative 14. But now we see, well, I have an x here and an x here. I have two x's. I could subtract 9x, put the 9x over on that side. But now, okay, I have x's here, so we're kind of caught with our current technique of operations on both sides. But now we can use this new technique we've learned. We can now rewrite this quadratic in factored form. So it's pretty straightforward for us. Find two numbers that add to 9 and multiply to 14. And those numbers will be 7 and 2. And now we can use that zero property we just talked about, in that now I have something times something equals 0. That means I know that either this or this equals 0. And this is going to allow us to solve the equation. So now we begin to see the advantage of factoring and why we do it. So I know x plus 7 has to equal 0, or x plus 2 has to equal 0. So I can solve this, x equals negative 7, or I can obviously solve that, x equals negative 2. Okay, so what we're getting are two answers, and we expect that, because remember, we have this quadratic. We have a plane and we have a quadratic. There are two values. There's a value here and there's a value here. So what we're starting to see are the quadratic is kicking out these two possible answers that we see. We could take either one of these, plug them up here and check and see if it works. Let's try whatever, negative 2. I'm going to put negative 2 in here. Negative 2 squared is 4. Okay, 9 times negative 2 is negative 18 plus 14. 4 take away 18, negative 14 plus 14 equals 0. Let's try this one. I can rewrite it in factored form. Try to find two numbers that add to negative 17 and multiply to 30. That'd be negative 15, negative 2. I use the zero property. So that means the first one must be equal to 0, or the second one has to be equal to 0. So I just set them each equal to 0. then I solve. And that gives me, again, my two answers. We see these two answers being kicked out. The third one, we see it's not a trinomial, but we can still use common factoring. Remember, the goal is to get it written as a product. The goal is to get it written as 0 equals a times b, or the other way around is fine. A times b equals 0. It's the same thing. So I know that because this is a product, this times that equals 0. So either the first thing, x, is 0, or the second thing has to be equal to 0. Now this may take me a few steps to solve, but that's fine. This is just a linear equation. This is a two-step equation, and we've done millions of these. I just subtract 5 from both sides and then divide by 2. I'm going to leave it as a fraction for now. Okay, we have this quadratic. It may not be in that perfect quadratic initially form first, so I just subtract 15 from both sides. So this 15 comes over here, it just becomes negative 15. And now it's a complex trinomial. So we've tackled complex trinomials. I find two numbers that add to the middle, multiply to the first times the last. Okay, we've done lots of factoring on this. I see now my 3x minus 5 is a common factor. So that comes up front. And I use my 0 property and solve for x. So let's try an example. Suppose you kick a ball off a cliff. You're up here on a cliff, you kick the ball. How far does it go away? We're trying to find this distance down here. How far away is it? So we have this path. The ball takes a path described by the equation. H is the height and d is the distance from the cliff. To find this d, this value of d, I'm going to set my h equal to 0. Imagine here's my vertical axis. This is 0 down here. This is my height. So I set that h equal to 0, and that should give me this d value when it occurs. So I set it equal to 0. Now, I actually want this first thing to be a positive to allow me to factor it. So I'm going to use this little factoring trick. I'm going to factor in -1 out of everything, which we're always allowed to do. And when I factor out a -1, I'm then going to actually divide both sides by -1, and that divides out on the right-hand side. And that leaves me with this quadratic here. And now I can just do my usual factoring. Two numbers that add to -5, multiply to -84, -12 and 7. Set each equal to 0. And therefore d equals 12 or d equals -7. So let's go back to the diagram here for a second. And I see, okay, here's my d equals 12 meters. Okay, here's my 0, here's my 12. That's perfect. But what was that -7? How does that -7 get here? If this, if this is my 12, and I maybe think this is sort of my, my whatever, the highest value. What's the -7? And what I realize is that the quadratic, our algebra thinks that this quadratic goes here and goes actually through the cliff and down over here on this side. And in theory, the parabola extends back through the cliff, the mathematical version of it. And that's where the -7 is. So the quadratic, our algebra is actually giving us both theoretical possibilities. It's giving us this 12 over here, and it's giving us this -7. The algebra doesn't realize this is a cliff and it's not allowed. It just kicks out both possible values. So we have to be aware of that in our problem, and we obviously would reject the -7. It doesn't make sense, and we would accept the 12 as the correct answer. So based on our example, we would discard the -7, and we would accept the 12 as correct. That's it.